As we begin Unit 1B, we are going to start by talking about perfect squares and square roots. These two ideas are inverses of each other or opposites of each other. When you square a number, the opposite is taking the square root. So it's a perfect combination. Our essential question is, how do I find perfect squares and square roots? Now you are going to want your calculator for this lesson, so if you haven't picked one up yet, please press pause and grab one quickly. All right, how do I square a number is my guiding question for this section. And we square a number by raising it to the second power. Please remember that 4 to the second power, or 4 squared, means 4 times 4, which is 16. So at the beginning, these are fairly easy to do. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared, 7 times 7 is 49. 8 squared, 8 times 8 is 64. 9 squared, 9 times 9 is 81. 10 squared, 10 times 10 is 100. 11 squared, 11 times 11 is 121. 12 squared, 12 times 12 is 144. Now, if you've memorized your multiplication tables, that's probably as far as you have memorized. However, let's pull up our graphing calculator here, and let's look at 13 squared. Okay, so I can do it one of two ways. I can either do 13 exponent squared, entered, and that's 169. Alternatively, your graphing calculator does have a special button for squaring a number. So I can do 14 and then diagonal from the 7. On your graphing calculator, you should see x squared. Okay, and here it is. What I'm talking about, go diagonal to the left from the 7 on your graphing calculator, and you should see that button. When I press enter, it will do 14 times 14, which is 196. All right, 15 squared, using my graphing calculator, is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361, and 20 squared is 400. Now these are the basic perfect squares. We say that 25 is a perfect square because 5 times 5 is 25. And you can, in elementary school, when they learn about perfect squares, they actually get out little square tiles and they make squares. 5 squares down, 5 squares across, and build a square out of 25 tiles. So each of these numbers, 25, 100, 49, all of the numbers I wrote in blue, those are called perfect squares. You absolutely have got to memorize up through 15. Okay, up through 15, you need to know quickly the way you know what 3 plus 2 is quickly. Yes, you can always use your graphing calculator to find these, but when you are using your graphing calculator for very basic computations and very basic knowledge, it slows you down and it takes a lot longer to accomplish problems and finish work than it should. Okay? 16 through 20 are nice if you have memorized, but they're not critical. So all of the answers to these problems above, all of the things I did in blue, are called perfect squares. So now that we know how to find a perfect square, either using our multiplication tables or using our graphing calculator, the question is, how do we find the square root of a perfect square? Okay, the opposite of squaring a number is finding the square root. Squaring a number and taking the square root are inverses. Opposite and inverse mean the same thing mathematically. Okay, they undo each other, just like addition and subtraction are inverses or opposites. Multiplication and division are inverses or opposites. So the square root of a perfect square is the number that you square or raise to the second power to get it. So let's think about this. 16. 16 is 4 times 4. So the square root of 16 equals 4. 100 is 10 times 10. So the square root of 100 is 10. 81 is 9 times 9. So the square root of 81 is 9. 225. Now, you may or may not know that one because it's not part of the regular times tables. So let's take a look on where we can find this on our graphing calculator. All right, the square root button, you'll see the symbol in blue right above the x squared, okay, that we just used. So we have to press second x squared in order to get the square root symbol. 225, enter, and we find out that 225 is 15 times 15, so the square root of 225 is 15, right? 4 squared equals 16, so the square root of 16 is 4. 10 squared equals 100, so the square root of 100 is 10. 9 squared equals 81, so the square root of 81 is 9. And 15 squared equals 225, so the square root of 225 is 15. So, if you are trying to find the square root of a number that's not a perfect square, we, at this point in the year, will be estimating. In Unit 9 of Algebra 1, you'll learn a way of getting a more exact answer, but for now, we'll just estimate. So the square root of 6, right? I can do 1, 2, 3, 3 by 2. I can't get a perfect square, right? I'm missing this row down here. But I do know that it's less than 9, because I drew in this bottom row with 9 pieces. And it's greater than 4 because 4 is part of my original drawing. So I know that the square root of 6 has to be between 4 and 9. Square root of 5. Okay, so we're trying to decide which two perfect squares 5 falls between. And I like to write my perfect squares down. So 1, 2 times 2 is 4, 3 times 3 is 9. Okay, right there. So the square root of 4 is smaller than the square root of 5, which is smaller than the square root of 9. I'm between those two numbers, which means 2 is less than the square root of 5, which is less than 3. The square root of 4 is 2, and the square root of 9 is 3. So if I have a 3, and 2 and 3. Okay, and the square root of 5, is 5 closer to 4 or closer to 9? And 5 is definitely closer to 4, so I'm going to put the square root of 5 closer to the square root of 4. Another way to look at this, square root of 4, square root of 5, square root of 9. All right, another way to do this is to use our graphing calculators to help us out. So I'm going to look here for the square root of 7. Let's go to my graphing calculator. The square root of 7, second, x squared gives me the square root key, 7, enter. So this is 2.6457, on and on and on and on and on. So the square root of 7 is bigger than 2. And it's smaller than the next whole number after 2 is 3. All right, let's look at the next one. The square root of 10, second, square root, 10. It's bigger than 3 because we're starting with 3, 3.16, on and on and on. So it's bigger than 3, but it's smaller than 4, which is the next whole number. Okay, 18. Let's see here. Second, x squared gives me the square root symbol, 18. The square root is bigger than 4, but less than 5. All right, so I'm going to do these on my graphing calculator, just in my hand. The square root of 17, 4 is less than the square root of 17, which is less than the next whole number is a 5. The square root of 230. Let's see, 15 is less than the square root of 230, which will be less than the next whole number is 16. 35. 5 is less than the square root of 35, which is less than 6. Now 2, you should be able to do that one in your head, right? 1 is less than the square root of 2, which is less than 4. So, oops, sorry, not 4, 2. Because the whole number after 1 is 2. All right, on this set of notes, I accidentally left in the questions for you, so you don't have to do that. But you should write me a couple sentences as a summary. Be sure to explain how to find perfect squares and how to find square roots.